Hey guys, I put stats on the middle of the page, so hopefully you guys can find this video easier if you're getting it off on my iPad. But we are working on Chapter 4 review today. Hopefully you guys have started this, and I'm just going through and figuring out what the correct answer is, and you guys are checking. But if you're going through this for the first time, make sure that you are understanding what's going on as we go through it. And if there's any of them that you don't quite know how I got it, maybe put a star by it or like circle the number, and then I can go back through those with you again before you take this test, which is on Thursday. Okay, a bunch of people are gone tomorrow for FFA, so make sure that you are ready for a test on Thursday. All right. I'll hopefully try to go through this one kind of fast. The following table contains data from a study of 2 airlines which fly to small town USA. If one flight is selected, find P on time and Upstate Airlines. Okay. So on time and Upstate Airlines. I'm going to do some adding here. So these guys added together is 76. These guys is 11, making a total of 87. That is 39, and that is 48, which makes 87. Yes, okay. On time and Upstate Airlines. All right, so on time is these two, and Upstate Airlines is this one. So only 43 are both on time, which is this category, and Upstate. The and is where they overlap. This is the only section. This one's only on time, but not also Upstate Airlines. I hope that makes sense. 43 out of 87. I don't know if that reduces, but let's divide. 43 divided by 87. And that is 0.49 whatever, or 49%. However you want to write that. Any of those will work. Okay? All right, number 2, a firm sells trend projection and seasonal factors to simulate sales for a given time period. It assigns 0 if the sales fall, 1 if the sales are steady, and 2 if it rises moderately, 3 if it rises a lot, okay? The simulator generates the following output. Estimate the probability that sales will rise at least moderately. Moderately is 2, and at least moderately would be a 2 or a 3. Right? Raising a lot is at least moderately. So anything except 0s and 1s. So we're looking for 2s and 3s. So this one, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 out of, does it say how many there were total? Ugh, I gotta count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24, 25, 26, 27, 28, 29, 30, 31? Is that right? That sounds kind of a silly number. Let me count again. Hold on. Nope, 31. 16 over 31. And whatever that comes out to be is 0.52. Whatever. Whichever one you want. Okay, there's that. Number 3, I'm going to do some adding first because they might ask this. 122, 21, which is 143, and 115, and 28, and 143. Yep. Okay. All right. If one of the results is 1 is randomly selected, what is the probability that it is a false negative? The test indicates the person does not have the disease when in fact they do. Okay. False negative. Okay. All right. What's the false negatives? It's got to be this one or this one. That's a false negative. If they get a negative result, they should not have the disease, right? This is what should happen. So that means this is my false negative, right? They shouldn't have the disease and get a negative result. So that 4 is a false negative. 4 out of 143 is false negatives. What does this probability suggest about the accuracy of the test? If I do that as a decimal, that is 0.03 or 0.028, I guess. We can go 0.28, whatever. That's like less than 3%. I think that's okay. I mean, typically you want no false negatives and no false positives, but if that's the case, that's a pretty low, and no test is 100% positive, and that's a pretty low number of false negatives. So what does the probability suggest about the accuracy of the test? Pretty accurate. I don't feel like I spelled that accurate. I don't know, maybe I spelled that wrong. Pretty accurate, because that's like less than 5% negative or false negatives. So that sounds okay to me. Flip a coin twice, create the sample space. Sample space is just listing out the possible outcomes, and we do that with like a little squiggly bracket. If you flip a coin twice, 2 times, you could get a heads, a heads, tails, a tails, heads, or a tails, tails. Now, how do you figure out how many should be in there? Like I had 4, right? How many should there be? If I flip a coin twice, that's 2 different things that could happen, right? And it could be heads or tails here. It could be heads or tails here, right? So 2 events, that means 2 spaces, 2 possible outcomes in each. So 4 total, because 2 times 2 is 4. So that means 4 total outcomes in, and that's how many my sample space has. So I know that I had them all, okay? Swinging, Sammy's score, batting prowess was simulated to get an estimate of the probability that Sammy will get a hit. 1 is a hit, 0 is an out. The output from the simulation was as follows. Estimate the probability of getting a hit, and a hit is 1. Okay. Oh, this is, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 out of, I don't know how many. Ugh. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42. 20 over 42, which is 10 over 21, which is a little less than 50%. 0.476. Okay, or 47.6% is his hit score. Whatever. Okay. 6. In a certain class of students, there are 11 boys. Oh gosh, 7 girls, 5 boys from Winnetka, 4 girls from Winnetka, 4 boys from Glen Cove, 4 girls from Glen Cove. The teacher calls upon a student to answer a question. Was it probably the student will be a boy? All right, here's what we're going to do. I'm going to do a little table. Do I have room to do a little table? Let's do my little table right here. Okay, this is going to be a frequency table, also called a contingency table. We got boys here, we got girls here. Okay, my first one is WIL for Wilmette. The second one is WIN for Winnetka, and G for Glencoe. All right. All right, there are 11 boys from Wilmette and 7 girls. 5 boys from Winnetka, 4 girls. You probably could have done this without a table, but that's fine. 4 boys, 4 girls. Teacher calls upon a student to answer a question. Was probably the student will be a boy. You could have done this without a table. Boys, there are 20. Girls, there are 11, 15, 20. Oh, no, 35. So boys would be 20 out of 35, which is, you're fine. Oh, what is that? Oh, perfect. Okay, thank you. So if I divide by 5, 4/7, or a little over 50%, 0.57, 571 if you want to do 3 decimal places, whatever. Okay, I could have done that without a table, whatever. Assuming that a study of 500 randomly selected airplane routes show that 482 arrive on time, select the correct interpretation of the probability of airplane arriving late. Interpret this event as significant if the probability is less than. So, probability of on time equals 482 over 500. 482 divided by 500 is 0.964. Okay, probability of late is 1 minus that, 1 minus 0.964, which is 4.6%. No, 0.36, 0.036, or 3.6%. So is that a significant event? It is happening less than 5% of the time. So it would be significant. Yes, significant. And I'm going to say significantly rare because maybe that will make more sense to you. It's significantly rare. It's significantly rare for it to happen that a plane is late. Okay, I hope that maybe instead of using the word significant, you can use the word rare because that's what significant basically represents. Okay, determine whether the events are disjoint. Disjoint means not connected or can't be the same. So I always think of disjoint as being like this thing happening, right? Reading a book by Mark Twain and reading about Tom Sawyer. Maybe you don't know this. I will make sure that it's a little bit more clear on the test. But Mark Twain wrote Tom Sawyer, like a book on Tom Sawyer is like one of the main characters in like a lot of his books, I guess, or something. So that is this happening, right? Mark Twain, Tom Sawyer. He has several books that are about Tom Sawyer, whatever. So they are not disjoint. Not disjoint. Another name for disjoint is exclusive. So that would mean that this is inclusive. Not disjoint or exclusive means that it's inclusive. Either one of those things, okay? All right, evaluate the expression 8p4. 8p4. 8p4 is 1680. Okay, explain what this means. You are choosing 4 out of 8 with order matters. That's what that means. I don't even have a story problem context, but I can tell you that that's what 8p4 means. You're choosing 4 out of an 8 total with order mattering. Got it? All right, 10. I'm going to try to go fast. Okay, a study conducted at a certain college shows that 65% of schools graduates find a job in their chosen field within a year. Find the probability that 11 randomly selected graduates all find jobs in their chosen field within a year of graduating. Okay, 11, 3, 4, 5, 6, blah, 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 blah. Okay, I want to know the chances that every single one of them find a job. So what's the chances that this person finds a job? 0.65. What's the chances that this person finds a job? 0.65. Chances that this person finds a job? 0.65. And I'm going to do that 11 times, or just take 0.65 to the 11th power. And it's probably going to be a low percentage, right? If there's only 65% of them finding a job, the chances that all 11 of them find a job is going to be maybe low. They say negative, oh no, not negative. They say 0.00875 or 0.875%, like less than 1% chance that that is going to happen. Okay, which makes sense, right? If there's only 60% of any one person finding a job, 11 of them in a row, that's going to be a lot. All right, express the indicated degree of likelihood as a probability value. Your mother cannot have died 2 years before you were born. Like, that can't happen because, then you wouldn't be her. So the likelihood as a probability, what's the probability of your mother dying 2 years before you were born? 0. That's a probability. Okay, further the table. Let's find some, whatever these are. 4, 1, 1, 4 totals. That's what I was meaning, totals. 3, 2, 1 for a total of 4, 3, 5. I think 96 plus 339 is 435. Yeah, 435. Okay. All right. Fine. A test subject is randomly selected and tested for the disease. What is the probability the subject has the disease given that the test result is negative? Okay, I have to paraphrase. Probability has the disease given, that's what that line means, negative. Okay, so now I'm not looking at all 43 of them. I'm only looking at the negative people. Okay, so my negative people are my bottom number. That's 321. Now, of those people who have the disease, I understand that 96 people have the disease, but of the 321 who has the disease, 9 of them, 9 is your top number, right? Okay, so 9 out of 321, whatever that comes out to be. 9 divided by 321 is 0.028. There you go. Okay. All right. Of 1,232 people who came into a blood bank to give blood, this many had high blood pressure. That is awful. Estimate probably the next person who comes into the blood bank will have high blood pressure. Well, the only thing we have to go off of is what previous results are. So probability of has high blood pressure equals 397 over 1,232. 397 divided by 1,232. Did I do those right numbers? Yep. This is 0.322. So almost a third of people have high blood pressure. That's awful. Okay, sports drinks. There we go. Cola is $5.95. Root beer is $5.75. The lemon lime is $5.85. Oofda. Okay. This is 85. And this is 85. And this is 85. That's weird. Okay, yeah, that's right, though. 85 times 3 is a total of 255. Okay, those are my totals. Oh, my gosh. One of the 255s randomly. Okay, they give me the total. All right, find the probability in fractional form that a person is over 40 and drinks cola. And means they both have to happen at the same time. So, is this person over 40 and drinks cola? They drink cola, but they're not over 40. Over 40 and drinks cola? Nope. Over 40 and drinks cola? Yes. Over 40 and drinks cola, over 40 and drinks cola, right? This one's over 40, but not drinks cola, right? Over 40 drinks cola. So the only one that is over 40 and drinks cola is where they line up, which is 20 out of, this is of the 255. Okay, if we divide by 5, that is 4 over 51. 4 over 51, and they want it in fractional form, so I'm not even going to divide it. In one town, these are the hard ones. Oh, no, it's not. In one town, 66% of adults have health insurance. Was probably 4 adults are randomly selected in the town, and all of them have health insurance. 1, 2, 3, 4. What's the chances that this person has health insurance? 0.66. The second one having health insurance, 0.66, 0.66, 0.66. That is 0.66 to the 4th power. Okay, I'm going to guess that it's like ish a small number, right? If there's only a 66% chance of any one person having health insurance, the probability that all 4 of them do, it's probably going to be a little bit lower. And it is 0.189 or 190 is what it would round to. So 19%. Okay, which is, I mean, a little bit lower. It's not rare. It's not completely rare, but because it's not less than 5%, but 0.19, whatever. If a person randomly selected, find the probability that his or her birthday is not in May. Ignore leap years. Okay, there's 365 days in a year. How many days in May? 31. So there's a 31 out of 365 of it being in May. This is yes, May. 31 over 365, if I divide that, 31 divided by 365 is 0.085, we'll say. So that's the chances of it being in May. If I subtract that from 100%, that is 0.915 or 91.5% chance that it is not in May. Okay. Compare probabilities and odds. How can you convert odds to probabilities? Probability is want over total. Odds is want over don't want. How can you convert odds to probability? If you're given the odds, you add these two together, and that equals your bottom number for your probability, right? So if I have a 1 in 3 odds, right, that means my probability is actually a 1 to 4 because want versus don't want, that means total is 4 parts. Okay, 1/4. So that's how that works. All right, discuss the range of possible values for probabilities. Give examples to support this. Probability goes from 0 to 1, or 0% to 100%. Give examples to support this, like 1/2 is heads on a on a coin. That's an example of a probability. You could say rolling a dice and getting a 2 is a 1 in 6 chance. Whatever. Examples. Range of possible values. You could also say 0% chance. 0% chance. I don't know. What's a 0% chance of? 0% chance of rolling a 7 on a dice. Because there's no 7 on a dice. You could say 100% chance, which would be a 1. 100% chance that, I don't know, 100% chance of rolling a number less than 7, right? There's a 100% chance I'm going to roll a number less than 7 on a standard dice, right? Whatever. Okay, next. Statistics students plans to use a TI-84 plus calculator in a final exam. For past experience, she estimates that there is a 0.92 probability that the calculator will work. Because the final exam is so important, she plans on bringing 2 calculators in case one loses power. Does she gain much by bringing in the backup calculator? Now, here's the deal. Instead of taking 0.92 times 0.92, right? Okay. This is, we do this in reverse, okay? So the probability, I'm trying to find the probability of at least one working, right? Maybe they both work. I don't know. Maybe the first one works and the second one doesn't. Maybe the second one works and the first one doesn't, right? I don't know which one's going to work, but I want to find the probability of at least one working. So what I'm going to do is I'm going to do the opposite, which is the probability of none working, right? Okay, and when I do the probability of none working, I have 2 calculators. What's the probability that this one doesn't work? 0.08, because 92% chance of working, 0.08 chance of not working. The chance that the second one doesn't work is also 0.08. So I take 0.08 times 0.08, or 0.08 to the second power, right? Not times 2 to the second power. And it is 0.0064. I should have done that in my head. I don't know why I didn't. Okay, that's the chances that none work, or neither of them work, right? Okay, so the chances that at least one works is going to be 0.9936. Okay, so if I have a 92% chance of one calculator working and it bumps up to 99.36% chance, that's a pretty good idea of bringing a second calculator. Does she gain much by bringing in the backup calculator? Yes, because it bumps it up from 92% to 99.3% or 99.4%. Use the probability that she will be able to complete her exam with a working calculator. This is the chances that she will be able to complete her exam with a working calculator. Okay, an author has 6 different books in print. If those 6 books are stacked in random order, what is the probability that they are arranged in alphabetical order from top to bottom? Oh man, 6 books are stacked in a random order. Okay, so we've got 6 books, blah, 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 blah. Okay. All right, is that 6? 6 books stacked in random order. Does the order matter? Like if I arrange them in alphabetical order, is that a different combination than another one? Yes, it is, right? Like the order in which I stack them does matter. Like you might not think it matters, like realistically, you're like, who gives a crap about books, okay? But that's not like opinion based, right? Like, does the order matter? Is it a different combination? Yes, it is, okay? So this is a P if the 6 books are stacked in a random order. Now, what is N and what is R? N is the number of books that I have. There are 6 books. How many am I stacking? All 6 of them, right? So this is 6, P6, or in other words, you could do 6 factorial. You will get the same answer. 6P6. 6P6, and that is 720, or you can do the same thing, and it's 720, right? What is the probability that they're arranged in alphabetical order? There's one combination in alphabetical order out of 720. How about 7 different books? Okay, if I do 7 different books, it would be 7P7, or 7 factorial, and that's going to be a lot more combinations, right? It would be 720 times 7, or 7P7, which is 5040, or 1 over 5040, I guess is what it would be. How about 7 different books? Yeah, maybe they're asking for 1 over 50, 40. Okay, so it gets exponentially higher if you do more books than that, right? Because there's that many more combinations. Okay, all right, this is a huge long video. Sorry I took so long. There you go. Goodbye.